We have part 2 coming up here. We're going to go much deeper. Since I know a lot of people also here have used Azure before, hopefully this next couple sections are a couple services, including a couple of services you probably haven't used before, since they're very, very new. And we're going to talk about data, we're going to talk about containers, and orchestration. We'll talk about serverless. We'll talk about cognitive services. And hopefully it should be a lot of fun. So let's start by talking about data. And so, a couple things that we hear over and over again when we talk to developers on Azure is, please let me use the database of my choice. And databases tend to be a very personal choice, so people have strong preferences about them. And then the second one is increasingly, how do you enable me to use a database not just in a virtual machine where I have to manage this thing as using my own infrastructure, but increasingly, how can you provide it as a service and take care of things like patching and high availability and all those other things for me. And we now have, I think, a really good story about both those. So let's talk about SQL to begin with. How many people here are using SQL Server today? Great, thank you. If you haven't checked it out yet, definitely take a look at the new SQL Server 2017. It's in public preview, and the preview now actually does support a go-live license. And I think this is one of the most exciting, if not the most exciting, release of SQL Server we've ever done. And we're seeing tremendous usage of the preview already. And one thing that's cool about this release is it's the first release of SQL Server that will ship simultaneously with support not just for Windows Server, but also for Linux, as well as for Docker. And so you can now literally use SQL Server everywhere. You can run it on a Mac. You can run it on a Linux VM. You can run it on a Windows environment. And with the Docker support, we're actually increasingly seeing people start to take advantage of and run SQL as part of their CI/CD pipeline, as well as their integration environment running in a container. And so you can literally, and I'll show a demo a little bit later on, where I'm containerizing an app. One of the containers is a SQL instance on my dev machine. Then I can flip it to be a service in the cloud at production. And that provides a really nice way that you can do very quick testing and stand-up of environments for development purposes. With the SQL 2017 release, we also have a massive update to our query processor. And we're super excited with the benchmarks we're seeing right now. The performance for both Linux and Windows are basically the same. And the feature set is the same. And with our initial benchmarks, we're basically seeing the best TPC results of any database on any platform in the entire industry. And you'll see big improvements as part of that. This release also is one of the releases where you can actually pin your existing apps to the old query processor and old query processing plans, which makes it really easy to upgrade to as well. So while we have a lightning fast query processor is part of the release, you can upgrade all your existing apps to just use it. If you're someone who says, look, I love that you have a new query processor that's awesome, but I just don't want to have to recertify all my existing apps, the cool thing is, 2017, you can pin your old apps to use the old query processing plan, which basically means you'll get the exact same query engine that you used in the past, and then you can then certify your apps to use the new query processor on an app-by-app basis, which dramatically eases app compat and makes it really easy to kind of roll forward immediately. And then this release also has built-in machine learning support now with both R and Python. And so you can now write stored procedures that use R and Python and run them directly in SQL Server. And you can now use those, for example, to run advanced machine learning models directly inside the SQL store and do deep learning as well as a whole bunch of other real-time analytics against our in-memory database support. And we're seeing some pretty phenomenal apps as part of it. If you watched our data amp event from, I think it was last month or maybe it was the month before, there's a really cool app that a partner of ours built that looks at radiology exams for medical practices. And so the hospital was already storing all the patient data inside SQL. And they're actually now using the Python support, the R support, and then also the GPU support that SQL 2017 now has. So they can actually do machine learning on top of radiology exams against a library of 250,000 other chest x-rays they've already done. And they can much more accurately predict the risk of cancer based on what they're seeing in the scan. And those types of systems are now easy to build. And what's cool about SQL, of course, is you can use SQL not just in a VM, but you can actually now use it as a service. And SQL is really the only database platform out there where you can run everywhere. and have that flexibility and that productivity that you get when you run it as a service in the cloud using Azure. And all those features I just mentioned, including the R and Python support, are going to be available in the SQL database as a service. And so the same query plan processor I talked about and raved about is already deployed in SQLDB, and the R and Python support is coming this summer, and you'll be able to run those same machine learning models, the exact same code in both places, and have perfect symmetry across the two. The other thing we talked about 2 weeks ago at the Build conference is a new option we have with SQLDB that we call managed instances, where you actually have 100% compatibility with a full SQL server on premises. We even provide the same APIs that we didn't think originally made sense in the service because they were very server specific, but we now actually emulate those in the cloud as well. And what that means is you can take literally any SQL Server app you already have and lift and shift it into the cloud with zero app and zero database changes and have it just work now running as a service. And we're seeing kind of tremendous adoption in our preview of that capability from various large organizations that in some cases had like 10,000 apps that they built with SQL and .NET in the past. They can now effectively hoover those up into the cloud, run it as a service, get much better cost savings because they can also collapse a lot of those databases into elastic pools using Azure and not have to make any code changes in order to take advantage of it. DocuSign's a great example of one of those customers that's taking advantage of all this new SQLDB capability. They're one of the sort of unicorn enterprise SaaS startups out there and are used by literally millions of consumers today, both for enterprise purposes as well as for things like mortgages and buying houses. And they just announced 2 weeks ago that they're actually moving to Azure as their public cloud platform. And they're going to basically bring the same service everywhere around the world, being able to leverage the Azure infrastructure in addition to the existing data centers they already have. And a big part of it was because they're a huge SQL shop, and the ability to take their system that's been optimized for flash storage with SQL on premises and just now run it in the cloud as a service was a huge attractive point to them. So let's go ahead. How many people here have used SQLDB as a service before? About half the room. Okay, so let's start off with a simple hello world SQLDB demo, and then I'm going to go deeper and show off some new capabilities that hopefully even people that have used SQLDB will find new and hopefully interesting. So first thing we're going to do is just create a new database. I always love to do this as a way to kind of intro SQLDB. And so let me ask for people that haven't used SQLDB, how long does it usually take you to create a new database in your existing on-premises environment? A while. I'm seeing some smiles. Days? Weeks? Anyone take months? Someone here once told me like 11 months. That seemed really bad. Let's call it the Fred DB. And let's go ahead and create a new one here in, let's say, I'm just going to put my Europe demos. We'll create it here in Europe. To the dashboard. So I can set a bunch of stuff here. We're going to hit create. And what this is doing is telling Azure, please go stand up a new database for us. And so it's now going to Azure, provisioning the new database, a SQL database. It's wiring up an IP address, a load balancer, registering the DNS. And then it's going to deploy this database on 4 servers. So we run this in a high availability fashion. And that way, if any one of the servers has problems or any of the routers that serve those servers have problems, we can fail over automatically. And it's also going to configure this with automatic patching. So any OS patch or database patch will automatically roll out, as well as provide built-in backup and what we call point-in-time restore support so that I can always rewind the database to any point in the last 30 days. And get a new database with exactly the database, the state of the database before I performed a particular transaction, which gives me even richer support than backup as a way to do it. And now I have a fully functional database that I'm ready to use. So that's kind of how easy it is to stand up a new SQLDB, literally from scratch, and start using it. And because it's an elastic database, I can scale it up. So if I need more capability, I can do so. You might have seen, I think 2 weeks ago, we just released our support for 4 terabyte instances of SQLDB. So you can now scale databases up to 4 terabytes. You'll see even additional sizes come out over the next couple months. And because it's an elastic database, when I don't need it anymore, I can just hit delete, and FredDB is gone. And since I only pay by the minute, that basically cost me nothing to do that demo, and it's now gone from the environment. So a very agile way that I can do data management at scale and take advantage of it. So let's show off, though, something maybe new to even people that use SQLDB, which is, we'll start off by showing off some of the built-in support for improving performance. How many people have ever written a bug or written an app that had a bug that caused performance problems in a database? Few people have. The rest of you are amazing, or shy. So, we all have, I think, at some point done that. And, the problem is figuring out, A, that you did it, and then B, figuring out, what did you do? And, generally what we find is not everyone is a phenomenal DBA as well as a developer. And sometimes people don't have access to a phenomenal DBA that can help them understand why is the app suddenly running very slow. And sometimes the usage pattern just changes. You get more data, or the pattern just suddenly changes in such a way that your performance starts to go a little wonky. So one of the things we now have built in to SQLDB is, now is available general availability, is built-in performance analyzers. And so if you see this little thing show up in the top blade, it's sort of a relatively new UI addition. It's basically saying, we've noticed something that you could probably do better. And if you click it, you can also see it in the left-hand nav. You'll basically get taken to this performance recommendations blade that is now available to you, where we're doing automatic machine learning on top of your database, and we'll basically recommend to you how you can make it much, much faster. So for example, here, we're noticing, hey, the way you're actually looking things up, you don't actually have the right index set up for that lookup table, or for that particular usage pattern. We kind of go into details why we think this is better. If you click View Script, we'll actually show you, here is the non-clustered index you should create, and what it should be included with. And if you run this with SQL Management Studio, your app is going to get a heck of a lot faster without you having to change any code, as an example. Similarly, we often find cases where people are sending non-parameterized queries to the database. And again, you look at the recommendation. Here's how you can, in SQL, basically force parameterization, always with the query optimizer plan. Again, it'll dramatically improve the performance of the system. And these two recommendations alone would probably improve the performance of the database by about 80%, which means you don't have to keep scaling up your database and pay more. Instead, just follow these recommendations, and you can actually tune things pretty appropriately. You can snooze recommendations if you don't agree with them. You can say, come back in a week or a month once I have time, and I'll implement them. And then we also show you your tuning history, and we'll even actually show you how much did the recommendation, once you implemented it, did it actually save? And so we can even quantify the before and after based on it. And part of the reason we're able to do this now is just because we have millions of SQL databases running inside Azure. One of the things that we found with SQL, and one of the reasons why I think the SQL 2016 and SQL 2017 releases have been so strong, and they've been, probably SQL 2016 has probably been our fastest adopted version of SQL we've ever shipped, is because of all this recommendations and tunings that we've put into the system. And the reason we've been able to do it is because we now have millions of databases running as a service. And so we've been able to actually improve our query processor dramatically, because we actually now, for the first time ever, can actually see how the query processor is really doing against real-world systems when we have literally millions of real-world databases to actually look at where the typical usage patterns are. And now we basically bundle this up. You can now use with any SQL database automatically and take advantage of it immediately. How many people have ever had a SQL injection attack or a bug in their code that had a SQL injection attack? A couple hands went up. How many people don't know what a SQL injection attack is? My guess is you've had one. It's a pretty common error. And if you look at errors that people have in terms of a security perspective and where some of the bad data breaches have occurred, they often start with a SQL injection attack. And so what does a SQL injection attack look like? Let's just look at a simple one here. So I'm going to log in as a user into a site. And basically with a SQL injection attack, I'm going to bet on the fact that the person who implemented this, instead of using a nicely parameterized SQL query, maybe was a little lazy and just said, hey, if the username is this, pull the password. If the password equals the one that was entered, let them in. And if you write that as raw SQL, guarantee you, you will have a SQL injection attack somehow in the future with that. Because what someone could do if they're evil, and this page even conveniently shows you how, but you can write something like this, where you'll notice this user quote or 1 = 1 dash dash. And what is this doing? Well, this is basically betting on the fact that someone is manually concatenating a SQL string together. The quote basically terminates a statement or a clause, or then says, oh, if this is true, or 1 = 1. And guess what? 1 = 1 is always true, which basically means the user is always going to get logged in. And then just for good purposes, the dash dash is a SQL comment, which basically means that whole where clause, which has the real logic that you were expecting, just got commented out. And now, regardless of what the password is, I can now log into the site. And boom, I'm logged in. And if I'm an admin, I can start doing bad things. Alternatively, on that search query, I could go ahead and paste in another SQL injection attack, where instead of filtering based on who I am, I can pull all the data. And a lot of the data breaches that you see reports on the internet really start this way. And in all seriousness, if you don't think you've ever had a SQL injection attack, it's probably worth double checking your code, because if you're not super, super careful, it's really easy to do these things, unfortunately, too often the times. So one of the things we have built into Azure, which I highly recommend turning on, is support that helps guard against this. And it's called SQL Threat Protection. And so this is that database, and I have it turned on. And so one of the things when I turn it on is you'll notice, well, hopefully you won't notice, but if you do have a SQL injection attack, you'll see alerts start to show up in the dashboard. And in addition to kind of showing up in the dashboard, the other thing we do, which we strongly recommend, is fill out your username and your email when you set it up. And then we will automatically send you a mail, and these are scary mails if you ever get them, which basically says, hey, we think you're being attacked, and we actually think your database is vulnerable. And so we're actually looking at your real SQL statements, and anything that we see in that SQL statement, the same way we're using machine learning to tune the performance, we can actually use the machine learning to say, this looks like a really odd statement that would ever actually be really executed in a normal situation. This looks like a potential exploit. And we'll email it to you. You click that link. It'll also take you back into that dashboard. You can also set it up so that we can SMS you. You can do a webhook and do an immediate alert. And when you click on the security tab, then we'll actually show you, this is what we think happened on this system. And you can read more information, but we'll actually even show you here, this was ultimately what we saw executed against the database. Notice that 1 = 1 and the password equals foo. And basically it let the user in. And again, it looks like you've been attacked. I managed to swipe something that caused everything to disappear. That's exciting. In detail. And so this is sort of, again, a built-in feature you can turn on now, where we'll scan not just for simple attacks like this, but also very complicated attacks, as well as what we consider exfiltration attempts, where people are, again, writing queries to be able to pull a lot of data back, and what looks like potentially risky SQL statements to do that. And again, it's all automated, all built in, and you'll sleep better at night if you have this on. And I will say, we send a lot of these emails out each week, and for a lot of these people, they're like, I never would have known this. It's not a good email to get, but it at least helps you know immediately as soon as it happens, and it's a great protection to turn on in terms of any database system that you have. How many people here have turned it on? Good. Well, not good, but good that hopefully people are motivated now to actually turn it on in the future. And have you gotten any emails back from the system? Anyway, we won't ask. So, it's a little bit about SQLDB. Other cool thing we now have is additional relational database services that we just released or announced at Build and shipped the preview of that you can take advantage of as well. specifically our new Postgres as a service and MySQL as a service options as well. And these work just like SQLDB, so you create them literally the same dialog, it's just one thing down. And like SQLDB, we run them across multiple servers automatically. So it's built-in high availability. You don't need to buy 2 of them to get high availability, so that's a big difference versus if you're running, say, RDS on Amazon. Google has a Postgres service, but I don't believe it supports high availability yet at all. This has it built in automatically with every tier that we ship. This also has the built-in backup as well as point-in-time restore capability. And so just like you can with SQLDB, any point in the last 30 days, you can restore a database from that point. So literally any transaction that you run, that inadvertent drop table that you didn't mean to check in, you can restore the database from the exact microsecond before that transaction occurred. And it's 100% compatible with all existing drivers, libraries, and tools. Well, the cool thing about it, it's just like SQLDB, you can scale it up and scale it down elastically, which basically means no application downtime. And so if you want to go up in terms of performance, go down in terms of performance, you don't have to take like a maintenance window and have your app be down. You can scale it up and scale it down elastically. That's also quite differentiated from what other cloud providers deliver. So let's go ahead and go to machine 2 and take a look at a Postgres database. Oh, so we'd switch to machine 2. There we go. And so what I have here is, and maybe you didn't see it, I clicked a little link here, a Postgres database that I created a little bit earlier. Again, same management experience, you get the same kind of resource utilization built in, standard settings for getting connections, setting up security, etc. As I mentioned earlier, in the command shell that we have inside Azure, we do install the PG SQL command line tool and other common tools that are used to manage, in this case here, Postgres. We do the same thing for MySQL. And so if you want to run common commands, you can do it. We do support dump uploading. So you can also, if you have like a local Postgres database, you can dump it out into a file, and then you can basically just point that file at our Azure Postgres option, and then upload the dump, and your database is just there. And again, if you go PG SQL, oh, it's not. It's all right. It's because, well, what is the command in PG? I thought it was PG underscore SQL, but apparently it's not. I should go to the documentation. You're right. But in the interest of time, I won't. But is it P SQL? No, I'm bugged. Oh, it was P underscore. It worked when I did it yesterday, but apparently it was a different command than I remembered. So it is there, because that's how I got my database loaded here. Just to prove other tools work, I'm going to launch the PG admin tool. This is a GUI-based tool that you can download from the web that works with Postgres databases. And there is the one that I have inside Azure. And you can basically see databases. That's the database I was just working with. Oh, it's just pSQL. Okay, well, I'll try it again next time. Thank you. And this is now connected to that Postgres as a service option that I'm running inside Azure. This is going to bring in, it takes a few seconds when the tool updates it, but you should start to see some graphs show up on the bottom there in terms of performance and other metrics that are available. But this is the standard tool querying the database just like it normally would. And again, I can create tables, I can manage all my options here just like I would, and there you can now see some of the timing data is coming in. And again, I can just use the tooling on whatever platform I want, just like I would as a full Postgres database, because it is just a full Postgres database. Same is true also for MySQL. And again, gives you a nice set of options that you can now use regardless of what type of database you like. You can now use it as a service on Azure. So let's go back to machine number 1 and talk about some other database options that we now have. Ooh, I just did blank. So one of the things that is exciting about the cloud is you can now build apps at a scale that was sort of unimaginable a few years before, where you literally have, say, millions of transactions per second, or you're storing petabytes of data, and you're serving customers all over the world. And one of the things you got to think about in that model is how do you handle data at literally planet scale when you do that? And that's where we're super excited about a service that we launched and shipped 2 weeks ago, which we call Azure Cosmos DB. And the Azure Cosmos DB is really the world's first globally distributed multi-model database service. And what do I mean by that? So specifically with Cosmos DB, you can run it in a single region of Azure, or you can run it across multiple regions of Azure. And when you run it across multiple regions, we automatically replicate the database and all your data across all those things for you as a service. And so you can run it, for example, in UK South and UK West, and have a complete high availability solution where the data all stays in the UK. Or you could run it in UK, in the UK, you could run it in Australia, you could run it in Hong Kong, you could run it in North America, you could run it in South America, you could run it shortly in South Africa, and be able to serve a global audience. And if one of your users happens to be in Australia, instead of them having to go all the way to the UK to get the data, they could pull it straight out of our Sydney or Melbourne-based data centers and have sub-millisecond response time in terms of serving of that app. And that makes obviously an enormous difference from the user experience in addition to improving availability. What's cool about Cosmos DB is it's also what we call multi-model and multi-API, meaning you can store lots of different data formats inside the system. You can do key value pairs. You can store documents. You can do column families. You can also then store graphs. And I'll show off some graph demo in just a minute, where you basically have entities that have relationships from a graph database perspective that you can traverse, query, and work against. And we support multiple APIs. So we support a SQL-like API we call DocumentDB. We have MongoDB. It's a very popular open source NoSQL database. We've taken the Azure Table API and the Azure Table Storage API that we had before. We now support that API against Cosmos DB. And going forward, we'll have an option where you can automatically migrate any data that you're storing inside Azure Tables into DocDB. This gives you finally secondary indexes and a whole bunch of extra features that people have been asking for a long time, and much, much better performance with even higher SLA availability. We also support the popular Gremlin Graph API, which is an open source graph data source API, as well as Spark for doing analytic jobs on top of all this data. And then what's cool about Cosmos DB is you can start small. So you can basically start with, say, just a couple gigabytes of data, and then scale it up to be petabytes of data in the future. You can also start with, say, just doing 100 requests per second or operations per second against the database, and you can literally scale it up to over 10 million transactions per second against the store. 10 million transactions per second is a lot of transactions, especially when you're doing over petabytes of data around the world. The cool thing is it's really easy to do this. You also pay only for what you use, so it ends up being incredibly economical as you do this and can save you a bunch of money. And then what's cool about Cosmos DB is it's the only database out there that has SLAs across 4 different dimensions. Not just availability, which is what most cloud services do, meaning is the service up, but we also have an SLA around latency, so we guarantee your read queries always complete in single-digit millisecond response time. Similarly, we have SLAs around write, as well as around throughput, meaning the total number of transactions per second you can throw against the system. And then we also have guarantees around data consistency, so that if you're running across the globe in multiple regions, we can guarantee how fast the data is replicated across those regions. And if you go into the metrics view inside the Azure portal, we actually show you your SLA attainment in real time all the time. So you can actually see, is my database really hitting this metric? And you can always track it and see how it's doing. Jet.com, which you probably haven't heard of here, but they're a very large retailer in the US. They're now part of Walmart. It's a cool startup that started on Azure. They went live less than 12 months from the founding of the company on Azure. They got bought 2 years later for $3.5 billion by Walmart, so it's a great startup success story. And they drive a ton of e-commerce volume. They now use Azure and then Azure Cosmos DB across 3 US regions, since they're a US retailer. So they East, West, and Central US. That way they can have absolute fastest performance for the users regardless of where they are in the country, and it gives them a super high availability solution. On Black Friday, which is our biggest shopping day of the year in the US, they scaled up their Cosmos DB instance to be provisioned to support 100 trillion transactions that day. That's a lot of transactions. That doesn't mean 100 trillion orders. That would be nice. But basically, they're doing tons of machine learning and analytics on top of shopping carts in terms of what people are browsing. And so the way their unique value of their system is they're constantly hitting the system to get more intelligence out of it. And they could literally support that amount. And then what's more impressive is they saw a single-digit performance latency at the 99th percentile, which is what our SLA guarantees. No other system out there can do 100 trillion transactions in a day with 99th percentile latency of single digits performance. So with that, let's go ahead and show off this thing. And more importantly, let's go to machine 2 to do that. More importantly, give you a sense of how you actually develop with it. And what you'll see is it's actually pretty easy to do. So, let me show off a simple app that I have. It's a little bit more complicated than Fred, but so we'll launch the app. Great, it's running. So it's running on my local machine, going against the cloud. Anyone here Marvel comic fan? It's a developer event. It's usually, it works less well in a financial analyst meeting, I've discovered. But so this is a simple app here. It's a wiki, and so it's basically representing content information about all the Marvel comic heroes. And then what's cool is it's using the graph capability inside Cosmos DB to represent the relationships of the different Marvel comic characters. And so in this case here, I'm on the Tony Stark page. I could go ahead and ask, who are your friends? Hits the database, it brings back the friends list. And this is basically looking at a graph node, getting all the other nodes attached to it, and bringing it back as a single query. Now you could do this in a relational way, obviously, kind of a master detail style relationship. Where this gets cooler though is, let's say I want to actually track to see, who are, let's say, the enemies that, let's say, work for Hydra. So in other words, who are Tony Stark's enemies that work for Hydra, who's another character? This is very difficult to do in a relational model because you suddenly have to do a query where you really need to understand and traverse the relationships. You could do it, but it would be a very expensive query and just not as intuitive. The beauty about a graph model is you can now do this type of query and actually understand the relationships in a very intuitive way and get a very fast response time, again, in less than 10 milliseconds. So how did we build this? So let's look at a couple things. We can look at first the code, and then we'll actually look at the implementation of how we built the system. So the code to write this is pretty easy. Basically, this is a Node.js app. There's a .NET API, Java API, other APIs as well. In this case here, I just pulled in the Gremlin library, which is an open source library for doing graph-based API calls. And then I could basically write a query. So it starts with something like G-V with a hero ID. And then I can basically build up a relationship graph and execute it as part of the system. So pretty simple API in order to work against it. Let's go ahead and then walk through what it would take to create a database to store this data API that I can throw that API against. And so same way that I could create a SQL DB earlier, I could go ahead and say new databases, and there's a Cosmos DB option now available for you to use. Give it a name that's unique, and then one difference versus, say, the SQL or Postgres API or service is we give you an option in terms of what API you want to use. And so you'll notice that Gremlin graph API is in that list, as is MongoDB, as is SQL, as is table. It basically says, what is the default API I want to use? Where do I want to deploy my first region or first instance, and then hit create. And then this will basically stand up in 2 or 3 minutes a Cosmos DB instance. This is one I created earlier where I've already populated the Marvel graph data within it. And if you click on the Data Explorer inside here, once you've created it, you actually get a nice view, regardless of what API you pick, of what that data looks like. And so in this case here, I have a heroes collection. And let's look at what this data looks like. Again, it's graph data. And so what I should see here is, a representation of that Marvel comic details. Now, right now there's GUIDs, which are not super easy to see. If you click the style button, you can actually choose, let's use the vertex node as a name. You could also go ahead and map the color to the name as well. Click OK. And now it's a little bit easier now to see those different characters. And then more importantly, what is the relationship across those different characters as part of the system. You can also go ahead, and this is just the generic starting from the root node down. But if I wanted to, I could also write a custom gremlin query in here and hit apply filter. And again, see the results back in a pretty easy way. So I can get a sense of kind of how to work with the system even before I have to write code against it. But the beauty is now I have my Marvel comic character stored here. I can write queries against it. And as you saw, it wasn't that hard to write a little bit of glue code to call this from within any app and start working with it programmatically. Now, the cool thing about Cosmos DB is not just that it can store data, but that you can actually replicate it around the world. And so if I click the replicate data globally feature option here, you can actually see all the instances where Cosmos DB is running today with this database. And so if I wanted, for example, I'm not running it in Mumbai yet. Let's run it in Mumbai. All I have to do is hit select Mumbai. I click save. And this is now going to take this database and replicate it to the Azure region in Mumbai. And literally, just by clicking that and save, I'm basically now having my database replicated. I don't have to manually copy it. I don't have to stand up any infrastructure. This will all be replicated over the private fiber network we have inside Azure, so it never actually traverses the internet. It all stays secure and encrypted. And in a few minutes, depending on the size of the data, it will basically be live for me in India. And that way, if I wanted to stand up a Marvel version of this app in India, the users in India would basically see single-digit millisecond response time for this app. So pretty easy to replicate anywhere around the world. The other thing that we then have that's kind of differentiated versus other data stores is a way that I can control what we call the consistency model of how I work with this data. So in a traditional, say, relational database world, so if you're coming from SQL, SQL enforces what's called strong consistency. What that means is you write a transaction, and that transaction is guaranteed to be committed, and any subsequent read will always see that data off of that database. And it's a really nice property, especially when you're doing things like financial transactions. Strong consistency is really, really good. The downside with strong consistency, though, is what happens when you're running in a distributed fashion, where you have a database here in the UK, you have a database in Australia. In a strong consistency model, when you write something, you also need to guarantee that the write is committed in Australia if it's distributed. And that's going to take a while. And for certain things like financial transactions, that's fine, because you want to guarantee that if someone immediately makes a financial transaction in Australia, they see the exact same balance from what just completed in the UK. And we support that with Cosmos DB. What's nice, though, with Cosmos DB is, like other NoSQL databases, you can also choose to relax the consistency model for certain scenarios. And so, for example, I could say, I just want eventual consistency, which means that, say, when someone updates the Tony Stark wiki page with some new content, we'll guarantee eventually it will be consistent in Australia, but we're not going to block the transaction or the write of the update until it is. And so instead, you can write, complete immediately once it's guaranteed that it's persistent in the UK. So even if the power suddenly goes off, the transaction won't be lost. And then we'll provide, as part of our consistency guarantees, within a certain period of time, it'll be replicated in the UK. Benefit there is much, much faster performance. You don't have to have a reliance on the network. So if the network goes down, your app can continue to work. And it works great, for some scenarios. What's cool with Cosmos DB is, beyond just eventual and strong consistency, we also provide a bunch of other consistency levels that you can choose. So for example, session level consistency is another really cool feature. And with session level consistency, what we guarantee is when you write a transaction, if that same person then reads, they'll always see the data in a consistent fashion. This is really good, like if you're building an e-commerce site and you wanted to run it simultaneously in East and South UK regions for high availability. Data will always stay in the UK. If the person's adding stuff to their cart and then they suddenly go to the other version or the other region to read it, it'll guarantee that that cart items will always be consistent, but only at the user level. So if Bob is also shopping at the same time, his cart isn't going to be blocked by mine being updated. And so you can enforce at a session level consistency, which is a super powerful feature. And then there's a couple other different levels in between as well. So we have 5 different levels of consistency that you can choose from. It's pretty unique. What's nice also about Cosmos DB is you can set the default consistency level, but you can then also override it on a per scenario basis. And so if you're building an app that has content updates, you might say that's eventual consistency. If you're building an app with a shopping cart, that's session level consistency. And when they check out and you want to debit their credit card, that would be strong consistency. You can do that in the single database store and basically choose on a scenario basis which ones you want to do. I don't think any other data store lets you do that like we do. And then the other cool thing is when you click the metrics tab, we actually show you where you are in the SLA attainment. And so we're showing you your database, exactly what we promised and whether or not we hit it in terms of consistency. You can see here we are right now, which is good. One thing you'll notice here, which is kind of cool, this is the one graph. You might say, ooh, it looks like you're getting close to that. This is actually close in a good way. And this is another feature of Cosmos DB that certainly a lot of high traffic sites really appreciate. In this case, for this one here, we're basically saying that purple line is what you've provisioned in terms of capacity for the system. And you'll notice that blue line went slightly above that. That basically means for a brief period of time, this app spiked, had a big traffic surge of users, and went above the provision throughput. And in a traditional model in the cloud, if you try to go above your provision throughput, the system starts to throttle you. And a cool feature of SQLDB is we used to do that on a per second basis in the past with our earlier version we called DocumentDB. And what people end up having to do is provision for whatever the peak was. And again, this is just all cloud providers do it. With Cosmos DB now, we let you provision based on a minute granularity. And so what that means is if you have a sudden spike that lasts 15 or 20 seconds, it doesn't actually get throttled unless you use up your full minute of capacity unit. And that means you can handle these spikes of a couple seconds without having to over-provision the system. And what we found, for example, with Jet.com is they were able to cut their costs by over 40% because they didn't actually have to provision for absolute peak. They only had to provision for absolute peak in a given minute, which is much less than the per second version. And so that can enable you to also save dramatic costs. And so that's basically how easy it is to get started with Cosmos DB. There is really good docs now. So if you go and visit our documentation page inside Azure, we've got what we call a 5-minute quick starts. This is true for most of our services now. We're updating all of our services to have these. So pick your language. We got .NET, Java, JavaScript, Python, and where's that last one actually? Gremlin, I guess. Is it? Yeah. Cool. We have that one too. Hey, what is that? Oh, I'm curious. I guess it's the Gremlin specific API. Okay, so I was going to use some language I don't know. But basically, again, if you want to learn how to use DocumentDB with Java, you can go ahead and git clone a sample. Here's what the code would look like. And basically, we show you all the common scenarios. And you should be able to do that in about 5 minutes. And then we also have step-by-step tutorials that go into a lot more depth in terms of what's happening under the covers that are language neutral. And again, you can learn how to do everything here in a really easy way. And actually, so I'm on the docs. I should cover the tips, tricks. We have some good docs now for all these things with some easy getting started 5-minute tutorials for everything, as well as step-by-step documentation for all these things as well. And so if you haven't checked those out, we're checking out for some of the other services as well. So let's go back now to machine number 1. As I mentioned, the Cosmos DB support, Cosmos DB is now generally available. And if you were an existing DocumentDB customer, we've automatically migrated you to it. So your data is now there, but now you have more features. And as I mentioned, the table storage API is now available in preview. And so if you're an existing Azure Table customer, you can use that as well. And then in the future, we'll also go ahead and provide a way to automatically migrate your table storage to Cosmos DB as well with zero downtime. So you can now take advantage of all the new cool features as well. Let's talk about containers. How many people here are doing container or microservice-based development? Cool. How many people here are looking to do it in the future? Yeah, a lot of people. Okay. So, I mean, this is something that I think pretty much every team is thinking about, which is, how can I go to a more agile microservice-based model? But at the same time, how do I, and someone asked me during the break, how do I do that without having to rewrite all my code? I've got lots of code that I built over the last 10 or 15 years that wasn't really built for a container microservice-based approach. How do I go from where I am today to take advantage of it? So I'm going to hopefully answer both those questions in this next section. So one of the things we now have built into VS 2017, and we're updating it pretty regularly because containers are still bleeding edge and there's lots of new scenarios and capabilities coming out with them, is our new Docker and container tooling support inside Visual Studio. And this basically gives you a way that you can work with Docker-based containers, both Windows and Linux, on your local IDE and have a development, debug, test, deploy cycle that you can run entirely on your dev workstation. And then with our Visual Studio Team Services, we now have a really nice set of DevOps support for it. And what's cool is you can use this both for greenfield projects where you're building new apps from scratch. And you might be able to take advantage of, say, .NET Core, which is particularly well suited for containers because it's very lightweight, small working set, fast startup time, and can work on both Windows and Linux. But you can also take advantage of this with existing full .NET Framework apps or classic ASP apps from way back when, and run them inside Windows Server containers as well, and use that with the same experience. So what I thought I'd do is show off sort of a demo of what that looks like and how you can take advantage of it. And so we go to machine 3. We're going to try to do that. And this machine just went hibernated and came back, which is really exciting. So we'll see if the network changed or anything like that. And so if there's a weird container demo error, I'm going to blame it on the hibernate. But hopefully there won't be. So what I have here is Visual Studio loading up with a project. And it's a simple app that's a website that talks to a CRM backend. And it's implemented, if I zoom in here, in a solution that has two projects, one which is the service level backend and one is the web front end. And these projects are built with full .NET. So in this case here, 4.6, but it could be an older version as well. And they use IIS, they use custom IIS extensions, they use WCF. They use all the richness that we have in Windows and Windows Server, and this again is perhaps a code base that was started years ago. So the question is, how can I leverage Docker in this world, and what would that look like? And so one of the things that we've added now to Visual Studio 2017 is the ability to add Docker support into your existing projects. And so you can right-click on a project, add Docker support. And what this will do is run basically a wizard inside Visual Studio that'll look at the project, inspect what type of framework it's built with, and then this will go ahead and add a Docker file into the project by default, as well as a Docker compose file at the solution level, which basically indicates how this should be run in a container perspective. So what you'll notice here in this particular example is I'm using an image, a standard Docker image, which is the Microsoft /ASP.NET :4.6.2 image. This is a full Windows Server image. So this is not using ASP.NET Core. This is not using a Linux container. This is using a Windows container, which means that I have IIS on it. It means I have WCF and so forth. But I'm going to be running it, in this case here locally, but it could be on a machine, and be able to take advantage of all that, still using the Docker-based packaging model. And so I could use this Docker file if I wanted to. I could even write call PowerShell scripts as part of my Docker file. So I'm using the standard Docker file syntax to represent and declare what this container contains and how it should work. But I can still, again, add in my own extensions unique to my particular environment, but plug into this model. And similarly, I have a Docker Compose file, which will actually represent the relationships between my individual projects or microservices, and I can have them talk to each other using the standard Docker Compose mechanism, and that's all generated for me automatically inside VS. Now, again, in this particular project here, I've got a multi-service approach, and so what I'm going to show you right here is a version of the app here that I've updated, where I now have Docker Compose across both parts of the solution, and I have Docker files in both parts of the solution, and I just ran it. And one of the things you'll notice that's kind of cool is when I do that, I do actually have still full debugging support. So when I'm running this app now, I'm no longer running it on my actual dev machine per se. I'm now actually spinning up containers in the back end that have, again, Windows Server-based containers with those images running in it. And yet I still have full F5 support. I can basically debug it just like I expect. And then the cool thing is that first breakpoint was in the web tier. The second breakpoint is in the service tier. So I can actually even do cross-container debugging across multiple container images, even though they're running in separate Windows Server containers that are completely isolated from each other, and continue across the system. So easy way here that I can go ahead and debug now, run those isolated, and the beauty is I didn't have to change any code. So all I had to do was basically add those Docker file, add the Docker Compose, and then I'm basically leveraging the Windows Server container technology using the Docker framework all on my local system in order to do this. So I could take this, I could deploy it on premises using Windows Server 2016, which has built-in Windows Server container support, and we actually ship as part of Windows Server 2016 Docker management support as part of it as well. So you just get that with Windows Server 2016. The other thing I could do, though, is optionally deploy this in the cloud using an additional higher level orchestration framework that I might want to leverage. And to do that, it's pretty easy. We do have the ability to effectively just right-click and wire up a CI/CD process, similar to what I showed earlier when we did it with an app service. I can do the same thing inside Visual Studio. That can then go ahead and create a Visual Studio Team Services CI/CD environment. And so in this case here, you can see my build pipeline will build my Docker image. It'll push it into a container registry, and Azure now has an Azure Container Registry service. So instead of publishing it, say, to Docker Hub, which is sort of the public container registry, what we often see is enterprises and teams want to be able to push into a private container registry for additional security. You can do that now. And then I could basically load this into a container service running on Azure using a variety of different frameworks. The particular framework here I'm going to use as part of my release management is Service Fabric, which now natively supports both Docker as well as the Docker Compose syntax and overall approach. And with this single deployment command, I'll basically push take the images that were in the Docker container registry and basically load them into my Service Fabric cluster and be able to run them at scale in the cloud. This is what a Service Fabric cluster looks like inside the Azure Management Console. And what you can see here is I've deployed a 5-node Service cluster or Service Fabric cluster. So think of it as there's 5 raw VMs underneath the Service Fabric system. I could add or remove those if I wanted to. And then what's cool is I'm running 114 unique applications on those 5 nodes. And so one of the big benefits that containerization gives you, in addition to more agility and the ability to move to a microservice architecture from a design perspective, is the ability to save a lot of money. And in the past, you might have had a separate VM for each of your applications because you just said, gosh, I just don't want to risk this app changing something on the box and causing this other app to start breaking. We'll just run them isolated in individual VMs so that nothing will break and everything will keep working. Cool thing with containers is you can just basically containerize each app and get that isolation and then pack them onto a single set of VM, or a smaller set of VM or machines and significantly reduce your costs. And that's what we're doing here, where I can basically now have different dev teams pushing different containers and different updates to the application on a much, much smaller set of machines than I would have had on premises, and run it in a fully rich distributed environment like this. And then within, say, Azure, in addition to kind of doing things at a container management level, I can also basically look at all the monitoring support that we have built in, build a custom dashboard like this, where I can now look at how is the overall cluster running Service Fabric doing from a health perspective. So I can look at the overall network CPU across those 5 nodes. I can look at the container level, how are those 119 apps doing, and I can even then at a per app level create an application map so I can actually see how all the microservices and their dependencies are interacting and whether or not I'm seeing any application-specific failures all in one view. And so all the stuff I'm showing here you can now take advantage of and start using today. And what's nice is Service Fabric just went GA with the Windows Server container support. It also is GA with the Linux container support. And so you can actually, on a single cluster, have both Linux and Windows Server container images running together. And so you could take all your existing .NET apps, move them into that model. You could, if you had Java apps in your company, you could move them into the same model and run them in Linux containers on the same set of nodes inside the same framework using the same CI/CD pipeline. And then if you wanted to, you could add Python or Node or Ruby or Go or any other language into the environment as well on an individual microservice-based level and have them all participate with a single management, single scaling model that you can use anywhere. So let's go back to machine number 1. Talk a little bit more about Service Fabric. So as mentioned, it supports Windows and Linux containers. It supports both stateless and stateful microservices. So this app that I showed here was a stateless app. And so when I converted it to use Docker and Dockerfile and Docker Compose, it'll work on anything that supports Docker and Docker Compose. You could run standard Docker Swarm. You could use the Enterprise Docker Edition. You could use anything that supports that framework. The nice thing is with Service Fabric, you can optionally take advantage of some of our stateful APIs. And so if you wanted to do things like distributed state management or quorum management or leader election or some of the other primitives that enable you to build stateful services, you can optionally do that as well. And then with Service Fabric, we do support running on Azure. We support running on Azure Stack. And if you want to, you could even stand it up in, say, a VMware or bare metal server environment on premises or even in another cloud running inside VMs. So it gives you lots of flexibility in terms of how you manage it. And it's just one way that you can run containers in Azure. We also support with the Azure Container Service, Kubernetes, Mesos, as well as Docker Swarm. As I mentioned earlier, our web apps model with App Service now supports containers as well. So you can deploy a web app as a container. And then our Azure Batch Service, which lets you do batch processing of applications and distribute apps like HPC workloads in a very distributed way, also now support container-based deployment as well. And one of the cool features we just turned on is what we call preemptible batch processing. Think of it like spot price instances. And when you deploy a batch app, whether it's containerized or not, in the interruptible mode, we basically drop the price by about 80%. And so it's the cheapest way that you can kind of do massive batch processing in any cloud and gives you great economics as you do it. So that was a little bit on containers. Now let's talk about serverless computing. How many people here are doing serverless computing today? Great. How many people have heard of serverless computing? Great. We're going to show off a whole bunch of serverless computing demos. So what is, for the people that didn't raise their hand on either, what is serverless computing? Well, serverless computing gives you a couple of different benefits. One of which is an architecture that's very well suited for event-based processing, and also an architecture that basically enables you to pay on demand just for the server resources that are being used. And so instead of having a VM waiting to be able to process requests as they come in, with serverless computing, you literally only pay for the compute cycles that are needed to process that individual request. And so in a lot of cases, it can save you a lot of money. And it also is very useful when you want to build sort of an event-based system that needs to be able to scale to handle billions of simultaneous events happening at the same time. And the nice thing with serverless is it kind of guides you down a path where you can scale up and scale down very quickly. So with Azure, you can deploy code in a serverless way and respond to lots of different types of events. So an HTTP request coming in, a timer event, a storage change, like say a file was uploaded. You can also even respond to things like a CRM record change in either Dynamics or Salesforce and trigger code or a workflow to run. And we have a couple different services that you can leverage for it. One is called Azure Functions, which gives you a way that you can do on-demand serverless code. You can write it in C#, you can write it in F#, you can write it in JavaScript, and you'll soon be able to write it in Java and Python. Provides a really nice serverless model. We're going to show a bunch of demos in just a second. And the other cool thing is you can now use Azure Functions inside Visual Studio. So you can develop your serverless code entirely on your IDE with local development, debugging, and CI/CD support, and then ultimately deploy it into the cloud when you need to run it in production. So let's go ahead and show some demos of all this now and see what it looks like in action. So we're going to go ahead and I can just do new compute Azure function to stand up a new function-based environment. Here is one I've created, and we're going to create a new function. And so basically, this is our Azure Function Service. You can see here, in just a second, it'll show a list of functions that I already have deployed as part of the service. So I've got a couple ones here. Let's go ahead and create a new one. I created one yesterday called Scott Goo in Amsterdam. Let's create a new one here since I'm not in Amsterdam anymore. We'll call it Scott Goo and Fred in London. And you'll notice I can create a couple different templates here. In this case here, I'm going to create one which is an HTTP trigger. So this will basically run serverless code in response to an HTTP request coming in. We'll show off some other ones against GitHub and blob storage and queues in just a second. But for Hello World here, we'll create the simple Hello World one. This is a simple app template. Again, you can change it. We'll save it. We're going to run it. I could get this function URL. And then I just need to paste in the URL in an HTTP thing. It says, hey, enter a name. We'll say name equals Fred. And out comes the output, hello Fred. And so the app to do this, super simple. That's all the code. I didn't have to spin up a VM. I didn't have to deploy anything. That's it. And what's better is this isn't running in a VM. This is right now costing me nothing because no one's hitting that URL. I only get charged when a URL invocation comes into that URL, and I only get charged for the fraction of a second that that code actually executes. And that's part of the benefit of serverless computing. So if you have something that's a very occasional request, this can save you tons of money versus standard things. In addition to trying it out directly in the browser, you can also go ahead and use this test tool that we now have built in. So for example, if I could say hello London, I can add headers or parameters, payload bodies, and I can just go ahead and hit run. And you'll notice the output came back as hello London, and it shows me the HTTP status code. So it's an easy way that I can actually test things out all in a browser. We'll show in just a minute how you can use Visual Studio instead. But I just want to get across, getting started is super easy here when you want to use this environment. How many people here use GitHub? Number. Who here has wired up a webhook from GitHub? Who here has wired up a webhook with custom code in GitHub? Ooh, fewer hands, one. So let's go ahead and do that. So you can obviously build an API service today that listens on a GitHub event. And there's lots of frameworks out there that you can do it, but for a lot of cases it's sort of like, I just want to do something simple, and hey, maybe that's more work than I really care about. And so one of the things you can do inside our serverless function model here is very easily, I just closed it, clicked the wrong button. I can very easily wire up a function to do that. And so let me just look at like a super simple sample here. And if you create a new function, you can just choose one of these GitHub templates that we have already. And what this particular template does is just output some little script like this. Ooh, that was very loud. And it's basically, and it gives me a function URL as well as a GitHub secret. It's not a secret anymore, that you can copy and paste. And then you just go into, say, a GitHub project, click on the settings tab, GitHub's taking a while. This is GitHub, not Azure. Well, that's interesting. Okay, there it goes, came back. If I click on the webhooks tab here, I can go ahead and add a new webhook. And then all I need to do, there we go, paste in that URL, make sure you select JSON, paste in that secret, and then choose what events do you want to basically have GitHub push to you via the webhook. And you hit add, it's wired up. I already have one that I wired up earlier to that URL. And now if I go ahead and, let me just make sure this thing's running so you can see in the debugger. If I go ahead and say, let's open an issue, or I could respond on an issue here and say, hello, Fred. Posting this on GitHub. GitHub will automatically fire a webhook to my webhook event. And you'll notice this thing just output hello Fred in the console. And that's basically because this thing, in just 5 lines of code, pulled the value that was sent by GitHub and then just logged it to the command line. And that's literally sort of how easy it is to go ahead and wire up a webhook from GitHub or from anything else. And so this webhook stuff works generically. So you can wire up webhooks from other Azure services. And again, the nice thing is because it's running serverlessly, I'm not paying for some VM that's pulling stuff. Instead, I'm only basically responding to individual events as I need to. I can go further and also not just handle URL requests, but I can also take advantage of triggers that fire in a variety of other mechanisms as well. And so you'll notice here, we've got, again, a bunch of templates, but you can also wire up lots of other stuff. But one of them is, for example, to respond to a queue or a service bus message or a timer or, say, example, storage change. And so here's an example of blob storage sample. Again, this is the generic template you can go ahead and wire up. What I've done is I've listened specifically on a particular Azure storage account and said whenever a blob is posted here, fire off this function. And right now this function simply says this file of this size was uploaded. So very simple sample here. We'll run it, make sure it's running. I could then open up the Azure storage tool. Which is loading. I'm going to open up that storage account. This is a free tool. We have a Linux, Mac, and Windows version of it. And then if I go into, I can't remember which storage account I'm listening on. I think it's that one. Yep. I can then basically upload any file I want from my system. And so let me put that one there. Hit upload. This is uploading the file into my storage account. And what I should see in just a second is, notice my function just executed, and details about that file that was just uploaded are now available for me to use. So simple way there, again, I can trigger off of a queue, a storage account, timer, service bus, any number of things. We'll look at even more advanced triggers in just a few moments. Execute some code, and away I go. And as you can see, it's really easy to write it directly in the browser. Now, what I find generally is this model that we have is really, really easy to get started. And we generally get a lot of great feedback in terms of this editing experience. And it's great when you want to have just a couple snippets of code that you want to execute and kick off something and trigger. Where it's less good is if you want to build a full app in a browser that has like 4 inches of typing, is not as ideal if you're going to be managing thousands of lines of code. And this is something that I think other serverless platforms struggle with sometimes on other clouds. And one of the nice things that we have obviously with Azure is very rich tooling support inside Visual Studio as well. And so you can now go ahead and install Azure function support inside VS so that you can basically say, I want to create a new project, and specifically I want to create a new Azure function project. This will create a local class library project inside VS. And it's a class library, meaning you can use NuGet packages, you can add multiple files, You can reference other libraries that you have. So it's the full kind of standard code editing experience that you expect. And then you can effectively, from this class library project, expose functions that you can then run and deploy inside Azure. And so it's a tiny bit more to set up because you got to create VS and hit new than that sort of a hello world 4-line code. But as soon as you go above, say, 20 lines of code, it's a heck of a lot easier to manage. And this works obviously with source control. This works with CI/CD. You get kind of all the richness and the power of what you'd expect from kind of a more complete solution. And what's also cool is you get debugging, which is a godsend when you're trying to figure out in a serverless-based model what is going wrong. And so this local project we're going to look at here in just a second, I'm going to kickstart it, hit run. This is going to actually run the local Azure Functions runtime on my local system. So this is actually running the functions on my development machine, even though I'm listening with this function to a queue that's running inside Azure. So I can actually connect both online and local system resources. And so you can see I'm going to trigger on a queue. And then basically I get past a blob, and I get pointed to a document DB API that's pointing it's a Cosmos DB database. And we'll come back to this code in just a second, but let's actually first look at what the app does from a consumer perspective, and then we'll look at the code behind the scenes. And so I did not build this site. Let me first mention that. It's a cat review site. And our function is going to moderate what are posted from our cat review site. Anyone here a good big cat person? Anyone here a big dog person? Cool. Anyone here a big hamster person? That was what I had when I grew up. But anyway, let me post a picture of a cat. I'm going to say, "Aw, isn't this cute?" Post the picture. What this is doing, it's a web front end. It's uploading the picture in a blob storage account. It is then posting a message into an Azure queue that basically says, I want something to go moderate this. And the way this is going to work here is this Azure function actually just woke up and processed this request. And what the code is doing here is did a couple different things. It basically called off to a method that basically checked the text that was uploaded to make sure that all this was cute, didn't include profanity or say something inappropriate. And then it actually used a machine learning API to verify that this was actually a picture of a cat instead of something else. And then only if it was a cat and the text was appropriate was it marked as approved, at which point when we go back to our reviews website, that "aw, isn't this cute" message was successfully posted. Now let's go ahead and try something different. Let's go ahead and set a breakpoint on this, or actually not there, let's set a breakpoint here after the moderation's done. And then let's go ahead and try to cheat the system. So we're going to upload a picture of a dog. I love this cat. Post it. We're going to go ahead here. Function will kick off. Boom. We're now broken the debugger. And if we zoom in, you can see the text passes. So no profanity there. It wasn't a cat. And so this AI API has looked at the image and said, oh, that's not a cat. That's a dog. And as a result, when I hit continue, it finishes executing. I go back to the reviews. You can see there is no dog. If I go to rejected, there is the dog. So simple model there. And the beauty is I'm only running the code in response to an event. So I don't have a while loop. If a billion cats suddenly showed up on the site, it would scale to be a billion functions and then scale down to cost nothing. So it's a very scalable architecture, very easy one. And you're not offended by some profanity, we'll do one last one. Let's upload the picture of the cat. I think this cat is shit. We've uploaded it. Our function's going to kick off. We're going to check the image. We're going to check the cat. We now do have a cat. It did not pass the text. That was clean. And when we continue it, we will find that this ends up also in the rejected section. And there it is. So anyway, simple app here gives you a sense of how to develop a serverless app that's a little bit richer, how it can use some of this functionality and what you can do with it. And again, the beauty about this is I got a really nice local development environment. Thankfully, none of you figured out that URL. In my last talk, people started in the audience posting pictures of other things. That's something I have a bug. All of a sudden, my debugger keeps breaking, and I'm like, oh, someone in the audience is having fun. Anyway, it stopped. You can't do it now. Anyway, but gives you a sense there. And then when you want to deploy this, so we're developing all this locally, I can right-click, hit publish. And just like you saw with app services earlier, I can either create a new function app or I can deploy into an existing function app that I've already deployed into the cloud, and it will automatically deploy to this. And I can also wire up a CI/CD pipeline with VSTS and set up a complete continuous integration, continuous delivery flow there as well. So a really nice development experience. And again, because it's just a class library project, you can add any file you want into it. You can reference any NuGet package. It ends up being kind of a really nice development experience that you can use anywhere. So that's a little bit on Azure Functions. Let's talk about something else serverless that's pretty cool. We'll show off another fun demo, which is logic apps. So with logic apps, instead of running serverless code, you can actually run serverless workflows. And so these are basically declarative workflows that can connect to data as well as application logic and code, and run kind of more long-running activities that might be better expressed in a workflow model than just pure procedural code. And like functions, we have great support inside Visual Studio for building these, or you can also build these directly inside the browser as well. So let's go look at one that we've built. And so what I have here is a very simple workflow that I'll show you. You can use the Logic App Designer, again in the portal. This also loads inside Visual Studio. And this basically, this serverless workflow is going to execute in response to tweets. And so if you tweet something about Azure with the hashtag Azure, it will show up every 15 seconds. We're basically monitoring Twitter with this activity to basically see, are there tweets? I'm calling out to some other machine learning APIs with cognitive services to check this tweet sentiment. So in other words, is it a positive or negative tweet? I also can basically pass the data into what's called a key phrase API, where we'll basically categorize what is the content about and extract and basically come up with the meaning of the keywords, all with machine learning without you having to do anything. I can call off to a function, so I can write my own C# JavaScript code as part of this workflow as well and easily integrate it. And then in this case here, I am calling into a Power BI data set, and I'm populating a data set in real time with the tweet data, showing the tweet text, score, location, who created it, and the body. And then I have a declarative workflow that says if the sentiment is negative, post it into a Microsoft Teams room, sort of like a Slack channel where I can go ahead and see, my team members can see in real time what's going on. And I can also then open up a Dynamics 365 support case if I want to do automated response. And what's nice is all these things are built in, adapters and connectors that you can use, and we have a lot more. So this is just a list of some of the built-in connectors that we have in the product. We have Salesforce connectors, we have Google connectors, we have SAP connectors to on-prem, we've got Gmail, we've got GoToMeeting, we've got Instapaper, we got MailChimp, we got Office 365, and a lot more. And so you can basically plug in any of these, and you can also build your own connectors into the system. So if you've got existing legacy APIs, you can just throw in an app gateway in front of this, and away you go, or call the API directly. So what does this look like then in production? So we'll go here first. In the background, let me load this. And so what this is going to do is I'm loading up a Power BI dashboard, which is actually charting in real time what is the sentiment of tweets about Azure using that workflow we just created. And so you can see the good news is people are generally pretty positive, but there's a couple outliers that we might want to understand. And you can also see where are people tweeting about Azure around the world. This is all in real time. So this dashboard's updating every 15 seconds as new tweets come in, showing it. And this will work on my mobile phone, and it works obviously in a browser as well. And then right here, ooh, I hate Azure after the Redshirt Dev event. I hate it so much. I I actually have no Jeff works for Microsoft, so I think he's just trying to have it show up here, I hope. Jeff, a lot of your things are showing up as negative, even though many of these things seem positive. But this guy, I've been tweeting on the wrong hashtag all morning. Anyway, this is just the Jeff channel. Anyway, but anyone's tweets would show up here, and you can basically see them here, not family, but anyway. But this basically is showing what the machine learning thought was negative, pops it up. Again, I can see it in real time. I can basically have it go into a support queue. And the beauty is this is all running serverlessly. So I don't have VMs running. I don't have expensive hardware running. Basically, the compute cycles only execute when they need to. And if you click on the overview tab, you can actually see the monitoring and each of these individual activities that fires. You can basically see the full debug history of what they did, what the values were, what the branching structure looked like, and how long it took to execute. So this whole thing took 1 second, which meant I only paid for 1 second of compute, which means it didn't cost much at all. We have some customers now that are firing over 1 billion serverless events per day. One of them is a really big company. I'm not allowed to name their name, but they do 1 billion of these events per day. The cool thing on their bill is it costs them about $7.42 to do that 1 billion events, which makes them very happy, makes my CFO not so happy. But it's a great way, again, for a lot of these event-driven architectures, great way you can save money, and you can see they're kind of fun to do. So that's a little bit about serverless. Let's talk about cognitive services now. Since I showed off, oh, actually, let me show off a quick video of someone else here. Anyone ordered pizza from Domino's before? Cool, you're using Azure and you're using serverless computing. This seems like a particularly evil video to show you right while you're waiting for lunch. But let me show you a little video of them talking about their experience using Azure functions.
Domino's main customer demographic consume technology on a daily basis. It's part of their life. They have very little tolerance for solutions that don't run well or don't run at all.
We moved to a platform as a service model. We can roll out changes to any region and environment very quickly and also provision new environments much faster. Serverless computing will be the next evolution for us from platform as a service.
It's really handy moving our data around. We know at Azure Functions has infinite scale, so we can move as much data as we need.
We are using Azure Functions now in some components of our ordering system where a consumption model makes sense. You don't have to worry about scaling, provisioning. Those things are very easy with Functions. It's easy to deploy and you don't need to manage any of the underlying infrastructure for it. You don't need to configure scaling.
We only pay for that data that we in and those functions that we do use. We know that Azure is always going to be at the cutting edge of any cloud technology.
We can put the content closer to customers for a faster ordering experience.
Domino's is a company that never wants to be ordinary. We want to continue to develop and deploy meaningful tech, to continue to grow and expand the business, and we're willing to put our trust into Microsoft.
Lunch will be soon. So let me show two more sections real quick, and then we'll break for lunch. So we should be done in about 10 minutes. Let me talk about AI. How many people here are doing AI today? More people are. How many people here are data scientists? Fewer hands. Usually what I hear from people is like, gosh, I want to use the AI stuff. It looks so cool. I'm super excited. Problem is I forgot all the stats and all the math that I took at school. And for good AI algorithms, if you're building a new model, there's a heavy element of stuff you do need to learn in addition to the code in order to really be proficient in that experience. I feel really bad because I had to take all these math classes 20 years ago when I was in university, and I've forgotten almost everything of that because my first 15 years of my career, I never used it. And now with machine learning, gosh, I wish I'd actually remembered it. I thankfully still have all my books on my bookshelf at home, and so at some point I'm going to spend a week and just relearn math that I took 20 years ago so that I can actually build really advanced machine learning models, which needs it. And so what we're trying to do with Azure is both have a platform where if you are a data scientist, we have lots of great things you can take advantage of. So I talked earlier about the new NVIDIA P40s that you can use for deep neural networks and deep learning. I talked about the Azure Batch service. One of the things we announced 2 weeks ago at Build is we now have built-in deep learning model that you can use with Azure Batch, which allows you to use all that hardware, be able to spin it up, and literally do millions of compute core hours of training models at very low cost across our cloud. And we've got, with our data lake and a lot of our other key services, great ways that if you're a data scientist, you can really do powerful stuff. And what's cool then is we also have higher level services that we call our cognitive services that enable you to also still build intelligent apps that combine software and data, even if you're not a data scientist. And these basically include APIs like you saw in the previous examples where we can do image detection, we can do sentiment analysis, we can do key phrase extraction, and a bunch more. And all you need to do to take advantage of them is be a developer and call an API. And we're adding more and more of these APIs that you can take advantage of as part of your application. And they enable you to, again, do some pretty cool stuff. So let's go ahead and walk through a couple demos of this. I'm going to do one last thing here before I do it, which is I'm going to delete Scott Guthrie, which I forgot to do after my last demo of this. So what here is I'm going to use one of the APIs that we have built in, which basically does image and face detection. And so what you'll see here as I'm walking around is notice how there's a little square around my face. As I look at it, it roughly calculates how old I am and notices that I'm a male. I'm surprised, apparently. And it also looks at my emotions. So notice I'm neutral right now. I'm happy now. And you can see the little face. I find it's really hard to be sad or something. I don't know if it's my face or whatever. But I have to start crying or something, and I'm not going to do that for you. But anyway, this is sort of an example. This is simply API. All this is being done in the cloud, so there's no local processing or no local ML that's happening. Instead, this is all calling out to the cloud. And as an example of if someone uploads a picture, you can now do what Facebook or others would do, and here's the people in the picture. You just call an API, we'll return back the locations of all the faces in the picture. If you want to identify the people in the picture, here's a cool thing you can also do, which is upload images to us and train a model. So let's go ahead and search on Scott Guthrie. Oops. This is calling out to Bing. Those are not me. Actually, no. Oh, I misspelled it. Hold on here. You can name it anything you want, but it helps if you're trying to do yourself to put your own name in there. So I could search on this, and this will hopefully go out to Bing. I can pull a couple pictures of me, more hair. That is not me. Ooh, that is not me. I wish that was me. But anyway, anyway, I can upload images here. Many of these are from years ago. I could train the model based on it. And now, the cool thing is, if I go back to my demos, you'll notice still does face detection, still guesses my age, and now it actually knows who I am. Ooh. And again, you can upload any images you want on it. It even tells you kind of roughly 55%, 60% accuracy. The light here isn't perfect. Those pictures are a couple years old, in some cases 10 years old of me. But it's still able to use, and it looks at like your nose, it looks at your overall patterns. We all have unique ones. And so it can actually help accurately detect who you are. And that's just one example of the type of things that you can do with these machine learning APIs. Again, the sentiment detection, the content detection, we do speech detection. We're also doing advanced video processing. And so one of the cool video demos we now have is we can actually, in say a meeting or a movie, we have some movie studios using this with their very old catalogs. We can actually identify all the actors and then basically return back who said what when. And you can actually, we also do voice to text translation. So you can basically type in a query and it'll do sentiment analysis on the movie and pinpoint the scenes with the actors based on it. And that's all a couple API calls that you can go ahead and make. So being able to sprinkle these types of APIs into your apps together with things like Cosmos DB, really enables you now to build really intelligent apps in pretty meaningful ways and do some pretty amazing stuff. And as you saw here, it's pretty easy to take advantage of. It's just a couple API calls that you can go ahead and make. And we do have documentation on the site that walks you through how to make those calls and what it looks like. So last thing we'll do before we break for lunch is talk about, hopefully I got you excited if you're new to Azure, or even if you're on Azure, this bunch of all the stuff, and you're like, hey, I want to use it. But hey, I work for a company that isn't quite ready for the public cloud, or I'm trying to convince someone, hey, we got to use public cloud, and they're like, well, I'm not sure yet, or there's a reason we can't. So how can you go ahead and use it? And we hear this a lot, less so these days than we did a couple years ago, but there's still a bunch of reasons why people aren't using the public cloud yet. And that's one of the reasons why we came up with Azure Stack, which Azure Stack's an extension of Azure. It basically gives you the same Azure experience. So it's the same management portal, use the same APIs. You can use Azure Functions that we just saw. You can use App Service that we just saw. You can use Service Fabric that we just saw, and basically build applications on Azure Stack just like you would with public cloud Azure. But the beauty with Azure Stack is you can deploy it anywhere. So you can deploy it in your existing data center. You can deploy it in a partner or a service provider data center, and you have maximum control as you use it. So how could you use it? In addition to people that are kind of worried about cloud, there's a whole bunch of reasons where people love cloud but can't quite use public cloud for certain scenarios. And let's walk through like 3 examples that we often see and talk about a couple customers that are doing it. The first one here is at the edge or for disconnected scenarios. Great one is a customer of ours that's been using Azure for a couple of years, which is Carnival Cruise Lines. Has anyone ever gone on a Carnival cruise? No. They're one of the biggest cruise ship lines in the world. They love public cloud. They love Azure. They use our Azure Data Lake. They use our IoT services. They're doing fleet management across their more than 100 ships around the world. So they're big believers in public cloud. The challenge they had is how do they use public cloud on the ship when it's at sea? Because if they're in the middle of the Pacific or middle of the Atlantic, especially if they're in a storm and it's raining very heavily, the satellite to connect up the ship to the internet is not the most reliable thing in the world. And so if you have your safety systems being run on that would be a bad thing. If the AV system in there for letting people watch movies or play games doesn't work, you have unhappy passengers. And so the question for them was how do they actually update these systems on the ship to take advantage of cloud? And the beauty is they're now able to take Azure Stack, and so they're one of our pilot customers. They're looking to put an Azure Stack instance on every ship. Now they can basically develop the apps that they run on board the ship the same way they run the apps in the public cloud. They can use the same code, even they can do the same data sync, same database in both places, and now they can have one dev team cycle using whatever language they want to be able to go ahead and build a microservice-based architecture that works everywhere. Another scenario is around regulatory needs. This is an area where, for Azure, we've really, I think, are in a unique place. I showed earlier today all the places in the world that Azure run. One of the things we always promise is if you put data in an public cloud Azure region, it never leaves that region. So if you put it in our UK South region, it never leaves London. You put it in our UK West region, it never leaves the UK. And that's a promise that we make not just on our website, but we actually contractually guarantee it to you when you consume Azure, and so it's a legally binding contract. And that's a way that you can make sure that things that are require data sovereignty, say in the UK, always stay in the UK. But there's other businesses that you might have or other countries you might serve that have a different set of requirements and where there isn't an Azure data center. So an example would be one of our Azure customers today, which is EY or Ernst & Young. They're one of the largest 4 professional services firms in the world. They do things like tax audits and other professional services practices for customers all over the world. And one of their markets is Russia. And the EY is moving most of their customers to put all their data in public cloud Azure. And these are some of the most sensitive data documents in the world. If you're a US company, if you're a UK company, there's no legal reason why you can't use public cloud Azure. If, though, your market is Russia, there's a law in Russia which is you cannot extract or move any company data outside of Russian soil. That's a legal law. And so they can't do audits and store the data in a system outside Russia. The beauty is you can basically stand up an Azure Stack instance in Russia, and now you can have one application. You can use the public cloud for most customers in the world, but you can basically stand up an Azure Stack instance in Russia and meet every Russian local requirement with a single code base. So we're going to play a little video of them talking about this experience and how this is really changing how they think about cloud.
There's an explosion in innovation, technology, the digitization of business. Markets can be exploded overnight in a positive way or a negative way. Our clients look to us to help them take advantage of the opportunity that is just blossoming all around the world. Trust is really central to our relationship with our customers. Our advisory, tax, assurance practices are all technology driven. Developers are central to delivering that value.
Azure and Azure Stack allows us to have a single point of development.
We develop one solution, and we can run that in public Azure or Azure Stack. The fact that we're always targeting the same set of services, we can provide the same set of SLAs to our customers. We use the same PowerShell tools that we use today with public Azure in order to stand up all the environments. The combination of virtual machine scale sets and load balancers, we can even spin up Service Fabric cluster. Seems pretty striking to me. That is something that puts developers in the driver's seat.
Azure Stack gives us the ability to put Azure in countries where Microsoft does not have a full Azure data center. We are building on the digital platform and satisfying data privacy and sovereignty regulations in 140 countries around the world.
The possibilities are endless in being able to move applications, revisions of applications, and country-specific applications for data sovereignty or custom use cases from one central location, one central code base.
Our vision is really to enable a better working world. Our charge is to make sure that the technology we build and deliver serves our clients and preserves the trust that they are putting in us to do the work.
And then we also see for cases where people are looking to modernize an app in place, maybe there's a mainframe, an Exadata system, or some custom hardware where they need to be, their apps to be close to today, but maybe not in the future. The great thing with Azure Stack, you can stand one up next to your mainframe, start modernizing your apps, and at a later point, migrate the mainframe to the cloud as well, and not have to rewrite the apps. And Azure Stack is just one part of our overall hybrid cloud consistency promise, whether it's around identity, management security, data platform, and unified infrastructure. The beauty is this gives you lots of flexibility and options so that you can move to the cloud for any scenario at your own pace and what best works for your business. Last thing I'll just mention then, how many people here are delivering solutions like in a SaaS-based way to customers? A number of people are. In addition to all the tech, so we talked about a lot of tech here already. There's a bunch of great stuff that Azure does in terms of helping you from a business model perspective as well. We've got lots of SaaS companies on Azure today. Adobe, Autodesk, Sprinklr, Avid, DocuSign, Pro, Symantec, Milliman, and more. And one of the reasons why people like it is both obviously the tech, but also this ability to deliver your services to 100 million monthly active enterprise users that are already connected to the Microsoft cloud through Office 365 and through Dynamics 365. And one of the things that we do with Azure is make it really easy, for example, to integrate as part of that environment, which gives you a way you can easily sell your solutions and add a ton of value to our mutual customers. And so specifically with the Microsoft Graph and our common data model, we provide APIs that enable you to easily plug into all these different systems. And then with things like Power BI, which you saw earlier, things like Power Apps, as well as our Microsoft Flow technology, we also make it easy for the Office apps now to reach into your apps if you want to choose to expose data, to be able to more easily add value and integrate your solutions as part of an enterprise environment. So for example, with something like Power BI, an Adobe customer can take their marketing data out of Adobe, they can take their SAP data out of SAP, and now mash up their marketing campaigns and their actual order history to see what marketing campaigns actually drove which dollar value. That makes the Adobe solution more valuable that they're delivering and makes the customer more happy. And the great thing is Power BI is just built into Office, and so it's not hard to do. The other thing I just want to mention, a lot of people didn't know about, is something we call AppSource, which is a way that you can go ahead and basically share your application on the web. You can provide an integrated trial experience, and so we have easy ways that you can go ahead and enable someone to see a video, sign up with a single click that integrates it across Office 365 and Dynamics, so wires up all the security, and then suddenly the user has a good trial. And then the cool two things about AppSource that might not be immediately obvious to you is that whenever someone does that, we actually have an API where we'll call you programmatically and insert a CRM record directly into your CRM system. So whether it's Salesforce or Dynamics based, that gives you details on how to reach to that customer and actually follow up from a sales perspective to say, hey, can I help you with a trial, can I answer your questions, and so forth. And that's done automatically, and we now generate literally hundreds of thousands of leads a month programmatically to anyone in that system. And then if you build on Azure and you're eligible for our co-sell motion, we do one extra thing, which is in addition to giving the CRM lead to you, we also give the CRM lead to the Microsoft salesperson who actually manages that particular customer account. And we now credit that salesperson with 10% of the contract value if you close that deal in quota credit on Azure, which basically means our salespeople are incredibly incented to help you succeed in selling that product. And we're at Microsoft putting effectively money in our salespeople's pocket every time you close a sale to that customer if you run on Azure. And that provides a great way that we can help facilitate from a selling motion perspective. And we've seen some really great success with ISVs building on Azure as part of it. And it's a real win-win. The customer's happier, you're happier, we're happier, and we all succeed together. And so that's also something that we now do and can help drive your success, and be happy to talk more about that later. So just in closing for this first morning session, hopefully you saw a whole bunch of demos. I've lost track of how many we've done, sort of across the board in Azure. And hopefully even if you were an experienced Azure person, there was a couple demos there that were new. And hopefully you saw there, we're really trying to make it possible to take advantage of cutting edge innovations, containers, microservices, AI, and more. Do it in a secure, trusted way, and really enable you to deliver results with fantastic productivity and hopefully an experience that's really fun to do. We're going to break for lunch now and then come back in the afternoon. I got a tips and tricks talk. I've only ever done it once before, which was yesterday in Amsterdam, so I guarantee it'll be new for everyone in this room. And kind of walk through a bunch of tips and tricks where, again, if you're an advanced Azure user, I think you'll learn some new stuff. And if you're a new Azure user, there's hopefully a bunch of tricks that still make sense that you can easily take advantage of. And look forward to coming back in how long? 40 minutes? 40 minutes. And we'll come back and we'll pick up for the afternoon session. So thanks a bunch and see you again soon.